Hi everyone, and welcome to episode 4 of Programming Thor with Grant. I'll just do a wee recap of what we've learnt so far. So we've learnt how to initialize the Thor programmer so that it was down to a very simple patch. We made it more simple by getting rid of the filter, and then we had to look at the amplitude envelope, the ADSR amplitude envelope, and then we had to look at the analog oscillator itself. We cycled through the different waveforms available, and we put the octave up and down, and we had a quick look at the keyboard tracking and the semitone and fine tune offsets. What I'd like to do now is show how you can use the low frequency oscillator to create a vibrato sound. Now, vibrato is a change in the pitch of an instrument, a sort of fluctuation around its normal frequency, and it gives a pleasant musical effect. Now, the low frequency oscillator is, as its name implies, it's an oscillator, so it gives a cyclic waveform output, but it's low frequency, and it's actually lower than the audio rate oscillators, which is what the analog oscillator is. And the output from this oscillator is used to modify parameters of the other modules within the system. Now, the way to get vibrato, well, I can demonstrate manual vibrato by using the pitch bend wheel on the keyboard. So if I just play a note on the simple mono legato voice, that's pitch bend down, and then pitch bend up is. Now obviously that's more than a fluctuation around a centre frequency, so what we can do is reduce the range of the pitch bend and bring it down to just one semitone, which means that if you bend up it goes, and if you bend down it goes, and if we quickly alternate between the two we get a nice musical vibrato sound. But it's a bit of a pain to waggle the pitch bend wheel back and forward. So what we do is we take the low frequency oscillator and we get it to modify the pitch of the analog oscillator. Now there's no immediately obvious way to do that. And in order to accomplish that, what we need to do is have a look at the modulation matrix. Now, what we'll do is we'll just stick to this right hand block of rows here. The other two rows are slightly more sophisticated versions, but we'll just stick with the left hand block for the moment. What you have down the very left hand column is a source. Now if we click the down arrow here, it comes up with a list of all the sources of modulation that are available. So we want to use LFO1 as our source. And there we have it. And we want the destination of the output of LFO1 to be the pitch of oscillator 1. Now these are the different parameters of the oscillator 1 which can be modified by the source that you select. So instead of frequency, which is a slightly sophisticated method of changing the oscillator frequency, we go for pitch, which is more of a musical variation. And if I just play the keyboard, you'll hear that there's actually no vibrato there. What we have to do is increase this amount here from 0 to some higher value. So if I hold down the key and increase the amount of modulation, then you can hear the vibrato effect becoming more and more pronounced. Now, that was quite a freaky sound. The reason for that is that the rate of the LFO was at quite a fast frequency, so that's 18.9 Hz, so that's nearly 19 times per second. It's oscillating backwards and forwards, going above and below the main pitch of the oscillator. So if we pull that back to something that's a bit more realistic, maybe about 3.8 Hz, and we increase the modulation depth again. Maybe speed it up just a tad. So there's quite a nice musical vibrato effect. Now you can hear that when we press the note initially, it took a wee while to fade in. That's because the delay setting is set to 449 milliseconds here. So if I bring that down to 0, it comes in immediately. But it's quite a musical effect. It's quite like a string player to delay the vibrato, so that when the note initially comes in, it's on its middle pitch, and then the vibrato level gradually increases as the note is sustained. Now, what you can do is you can assign the mod wheel to govern the amount of vibrato by using the scale value. And that means that by pushing the mod wheel further up, the vibrato depth becomes stronger, and when it's down at the bottom position, the vibrato depth is 0. So if I select the scale source as being performance mod wheel, and I make the amount full on, so it's 100, so that covers the whole scale of vibrato from 0 up to 19 through the mod wheel. So if I just press it with the mod wheel down at the bottom position, and we'll make the maximum vibrato amount a bit more severe, just so you can hear the effect a bit more clearly. And there we have it. So you've actually patched the low frequency oscillator in to modify the pitch of Analog Oscillator 1, and we're controlling the oscillator depth, the LFO depth, by the mod wheel between 0 and 100% of this amount here. And there are several rows available in the modulation matrix, so you can take all different types of sources and patch them into all different types of destinations, varying the amount by various scaling factors. And this is really the heart of the power of Thor. It puts it into the league of modular synthesizers, but it's all in one box. So I think that's quite a lot to take in for one day, but certainly have a play about with the LFO rate, the delay time, and the scaling factor by the mod wheel. and just see what you can come up with. You might also want to mess about with the waveform shape of the LFO1. Triangle wave is quite similar to sine wave. It's a subtle effect. Square wave means it trills around the pitch value. And just have a play about and see what effect all these different parameters has on the way the vibrato sounds. So I think that about wraps it up for today's episode. So just, as I say, keep playing about, get a feel for how things work, and I'll see you next time. Bye for now.